Alright, hello and welcome guys back to another Usaco walkthrough here. Today we're going to be doing the 2021 January contest problem 3, just stalling. So about my upload schedule, yeah, I know I've been gone for a long time, but it's okay. I'm back now and I'm on the grind again. So another thing I want to say is thank you guys for 60 subs. The last time I did a recording of a milestone, it was 30 subs, so it's just astounding that we've doubled in the last few months here. So I just want to say a big thank you to the guys that have subscribed and supported me through this journey. So yeah, without further ado, let's get into it. Alright, let's just start reading here. So Farmer John is N cows, N is between 1 and 20 of heights A1 to A of N, and his barn has N stalls with max height limits B1 to Bn. So for example, if B5 equals 17, then a cow of height 17 can reside in stall 5. Alright, so the key takeaways from here is that the cows are defined by A, and the stall's limits of height, the height limits for each stall is defined by B. Okay, so in how many distinct ways can Farmer John arrange his cows so that each cow is in a different stall and so that the height limit is satisfied for every stall? Alright, so the key thing that we're taking away from here is that A and B, A is going to be the cows, B is going to be the limits, and so we have to fit A into B so that precisely each cow is in a different stall, and the cows basically can fit into the stall, like the heights are satisfied, the height limit is satisfied. So that means the height is either the same or less for each stall to the respective cow. Alright, so let's take a look at our input format here. So the first line contains N. Okay, so that's just how many cows. And the second line contains N spaced separated integers, A1 to AN. So yeah, there we go. Those are our cows' heights. And the third line contains N spaced separated integers, B1 to B of N. And these are just going to be the heights the height limits for the cows in each stall. And they're in the range of 1 to 10 raised to 9. Alright, so okay, seems pretty easy enough. However, the 10 to 9 might mean that we have to use a pretty big integer storage system. So, next one, the number of ways, output format, the number of ways Farmer John can place each cow into a different stall such that a height limit is satisfied for each stall. Alright, so this is just going to be like how many different combinations can we do, pretty much. That's how I interpret it. So, notice that the large size of the output might require the use of a 64-bit integer, like a long equals plus. Alright, so that kind of makes sense because the heights and limits are kind of big, so we don't know the range for each one in each test case. But let's take a look at this specific test case here and see if we can take some reasoning out of it. Alright, so we have 4 cows here, and in this case, their heights 1, 2, 3, and 4. And the height limits are 2, 4, 3, and 4. So, in this case, they say 8. Well, why is that? Well, we cannot place the third cow into the first stall since 3 is A3 and B1 is 2. So therefore, this cow cannot fit here. And similarly, we cannot place the fourth cow into the first or third stall, so we can't take this and place it in here or here. So one way to satisfy the height limits is to assign cow 1 to stall 1, cow 2 to stall 2. So that means it's just like, say this cow goes to here, this cow goes to here, this cow goes to here, and this cow goes to here. So yeah, nothing too fancy about this test case. So now that we know how basically the test case works and how the problem works out, we can start thinking about how we're going to basically turn this into an algorithm we can write down into code form. Alright, so let's try thinking about different approaches to tackle this problem. So I've drawn both arrays out on this white space here, and one of the first solutions that come to mind would just be to just try all the possible combinations of these stalls and see whether these cows fit into them. So that would definitely work because, of course, permutations and combinations are one of those solutions out there for Usaco that they work, but they're also really slow. So in this case, using a combination will result in O of n n factorial time. And in this case, I can tell you guys from experience, it will time out in this case because of the immense size of n. So in this case, we're not going to use the permutation. We're going to use basically a search method that's actually going to minimize our time complexity down to O of n. So how are we going to do this, you might say? Well, if we just look at this from a practical standpoint, we could try, say, first sorting them and see what that does. So if we sort them, that still brings us to 1, 2, 3, 4. However, the second one gets changed to 2, 3, 4, 4. And if we just consider this regular case here, we can see that if we go from the backs, because cows are measured by the height, and if the height is greater than equal to, that means they can fit in a stall. So we're going to start from the back because that's where all the because it's going to be from greater than great to less, or large to small. Sorry. So in this case, we have 4 and we have 4. So in this case, 4 is going to fit into one of these two slots. So we're going to circle it, and it's going to fit into one of these two stalls. Okay, that's fine and dandy. And okay, so we have 2 possible combinations there. And in this case, we have 3. Okay, and so in this case, 3 can, if 4 chooses one of these 4s, it doesn't matter. 3 can have 2 possible combinations as well. It can go into this 4. If let's just say that this 4 was taken by this 4, and in this case, 3 can take this stall that has max capacity of 4, and it can also take this stall. So there's another 2 combinations right there. And finally, we have 2. And in this case, if 3 takes either 3 or 4 right here, 2 can also take one of them. So it doesn't matter which one. So 2 can either take, let's just say that 3 is going to take this stall of max 4, and 2 can either take 3 or 2. Like that. So then we have another 2 on our hands. And finally, we have 1. So in this case, after all of them have been taken, 1 is either going to have either 2 or 3. In this case, it's going to be these 2. So in this case, 1 is going to only there's only enough space for one more stall to have one more cow in. So in this case, 1 is only going to have 1. In this case, we have 1, and 2 times 2 times 1 is going to be equal to 8. And that's our thought process right there. We're going to basically we're going to do a controlled search where we're basically going to see whether each stall is viable for cows to be in it. And we're going to start looping from the back to check, and from there we can do a controlled search. Alright, and in this case, A is indeed the correct answer. So now that we have a basic thought process of what we're going to do, we can just start coding. Alright, so I've just created this code that basically just going to read in the input, and I stored n as just a simple integer. So if you don't remember, basically Usaco recently changed their input-output style to, instead of input-output files, they actually use standard input and standard output now. So in this case, I just read both of them in as a long array. Make sure that you read because all heights and limits are in the range 1 to 10, 9, and they might require the use of a 64-bit integer, so like a long in C++. So a long in C++ is basically just like a long in Java. So that's what I used here. Just read them in and stored them. Alright, so let's first, we're going to basically create a method that's going to process this, because I don't want to deal with like confusing loop stuff in the main method here. So let's just call this, let's call it solve, I guess. And within this solve, we're going to have our 2 parameters. Basically, this is going to be the method that we're going to use to just basically solve the problem. So we're just going to put our 2 long arrays in there. And remember, what I talked about back here is basically that we're going to first sort them, and that's going to allow us to basically do a search. That's going to allow us to pinpoint the amount of possible ways we can configure the stalls to fit each cow. So we're going to do arrays dot sort both of them. A and arrays dot sort b. And then I've also created this global static variable here that's going to basically just going to be the count that's going to allow us to this is going to be returned in the end. So it's going to count how many possible ways we can configure the stalls. So let's just set count to 1 for now, because there's always going to be one. And actually there's not always going to be one, but this is going to be what we're going to multiply by. Remember, over here, because remember, each stall, it's going to open up a we don't know which. In this case, for 4, we don't know which stall it's going to use. It can use either this 4 stall or this 4 stall. We don't know. So that creates 2 possibilities there. And the same goes for 3. We don't know which one 4 picked. So 3 could pick either of these 2. And the same goes for 2. So in this case, we actually have to multiply, because it could really either be any of those. So we have to basically multiply those probabilities. So let's create our loop that's going to basically just so remember back when our workspace, we're going to loop from the back here. So let's just say in I equals a dot length minus 1. I is greater than or equal to 0. I minus. And let's see here. In this case, okay, let's create another method real quick before we finish this one. And let's call it let's just call it find. Oops. Let's see here. All right, let's not set it for long find. And we're going to add our array and another long. And first, let's add another count variable here. So let's make a method that's going to find the amount of possible ways a cow can fit into those stalls. So for example, in this case, when we have let's just make this more clear here: 1, 2, 3, 4, and 2, 3, 4, 4. We need a method that looks really ugly. We need a method that's going to basically let's say we have 4. Our cow of height 4. We need a method that's going to find how many possible stalls this cow can fit into. In this case, it's going to be 2. So yeah, let's write a method that's going to do that. So we're going to loop through the stalls. Oops. And from there is greater than D. So how do we know whether a cow can fit into a stall? Well, that stall has to be greater than or equal to that height. And else we're just going to break, because since we sorted both arrays and it's going to be from smallest to greatest, if the greatest one from the back is not greater than or equal to, then of course the one smaller than it is not going to be. So at that point we can just break. Okay, so let's go down here. Oops. And we're going to return our count. Okay. That's pretty swag there. And let's go back up here. I need to sneeze real quick. Okay, never mind. Okay. Okay, so next we're going to create a temporary variable that's going to find the amount of stalls that each cow can go into. We're gonna find the amount of stalls that each cow in the A array can fit into the amount of the different stalls in B. And first of all, if temp equals to 0, that means that we can return 0, since if none of the maximums fit, then in this case then we could just go to, if none of the maximums actually no, sorry. If none of the stalls fit, that means in this case, then we don't have to continue checking whether this cow fits in the stalls anymore. We can just go to the next cow. So we can just return 0 for that part. Okay, and then else count is going to be equal to count times so in this case let's see here so in this case we're going to basically multiply count by, remember, here we have to multiply those two probabilities together. So in this case, count starts at 1, so we need to multiply those possible probabilities. So in this case, we need to, let's see here, multiply count by the temp, basically how many stalls can fit, but we also need to consider that we've already counted a lot of them in the previous stalls. So we actually have to subtract a dot length and then plus I plus 1. So this is going to allow us to basically just subtract the ones that we've already counted. Oops. And basically give us the correct answer. And finally, when all is said and done, what are we here to do? Well, we're here to return count. And there we go. That should work. Alright, so I'm going to find my file real quick, and I'll turn it into Usaco website, and I'll see you then. Alright guys, welcome back. So we're on the Usaco website here. So let's just turn in our code real quick. Desktop. Oh no. Yeah, right here. Okay. Alright, so it's grading in progress, and it should be faster now that we've switched from input files to standard input output. Oh, sorry. I am very mistaken here. So, sorry, we created those methods, but now we actually have to implement those methods. So, let's try doing that now, right here. So, in this case, we actually have to plug in both of our arrays. So let's just do that right here really quick. Okay, solve A and B. Oops. Okay, that should work. And we can just go back and boom. See how it does. 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11. Alright. And 12. So yeah, that is just stalling just stalling the 2021 January problem 3 bronze contest problem. And here's the code. I'm gonna scroll through it. If you still need it, you can pause as you go along. And yeah, there you go. That's the problem. And yeah, so I like to first thank you guys for watching. I sincerely hope you enjoyed and learned something out of this. Hope you improve in your Usaco journey, wherever that may lie. So yeah, thank you guys for watching, and I'll see you in the next video. Bye.